In this video, we're solving a second-order differential equation using the method of undetermined coefficients. So for this example, we're going to be solving the differential equation y prime prime minus 4y prime plus 4y equals e to the 2x, with the initial conditions y of 0 equals 1 and y prime of 0 equals 0. The first step is to solve the corresponding homogeneous equation. So we're going to replace that function on the right hand side with 0. So we want to solve y prime prime minus 4y prime plus 4y equals 0. So assuming that y is of the form e to the kx, this will give us the characteristic equation k squared minus 4k plus 4 equals 0. So in this case, we can factorize. So we can rewrite this quadratic as k minus 2 squared is equal to 0. Therefore, k is equal to 2. So in the case where the characteristic equation has a repeated real root, we know that the complementary function is going to be y is equal to a plus bx, or multiplied by e to the 2x. The next step is to find the particular integral. So we know the particular integral is going to be of the same form as that right-hand side. So since we have e to the 2x on the right-hand side, we're going to expect the particular integral to be of the form e to the 2x. However, in this case, we've got a problem, because the complementary function is of the form a plus bx times e to the 2x. So we're in that case where the resonance rule applies. Because our trial solution duplicates the complementary function, we have to multiply by a higher power of x to make the particular integral independent. So we have a plus bx, so we're going to have to multiply the e to the 2x this time by cx squared to make it independent. So we're going to assume that the particular integral is x squared c e to the 2x. So from here we need to differentiate. So using the product rule, we get that y prime is 2x squared plus 2x, or multiplied by c e to the 2x. And then differentiating again using the product rule, we will get that y prime prime is equal to 4x squared plus 8x plus 2, all multiplied by c e to the 2x. So now we can substitute these equations into our differential equation, y prime prime minus 4y prime plus 4y equals e to the 2x. And this will simplify down to 4x squared plus 8x plus 2 minus 2x squared plus 2x plus 4x squared, all multiplied by c e to the 2x equals e to the 2x. So we'll notice here that a lot of the terms will cancel. So the 4x squared will cancel, the 8x will cancel. So what we're left with is 2c e to the 2x is equal to e to the 2x. So dividing by e to the 2x, we get that 2c is equal to 1. Therefore, c is equal to a half. So our particular integral is going to be y equals a half x squared e to the 2x. So the last step is to find the remaining constants. Our general solution is going to be the complementary function plus the particular integral. So y is going to be equal to a plus bx plus a half x squared, all multiplied by e to the 2x. Using our initial conditions, so the y of 0 equals 1 means that when x is equal to 0, y is equal to 1. Substituting this in, we'll be left with a is equal to 1. To use the next condition, we need to differentiate. So using the product rule, this will simplify down to y prime equals x squared plus 2b plus 1 times by x plus 2a plus b, all multiplied by e to the 2x. So placing the x's with zeros and the y with 0, we get that 2a plus b is equal to 0. However, since we know that a is equal to 1, This means that b is equal to -2. As we found the values for a and b, we get that y is equal to 1 minus 2x plus a half x squared, all multiplied by e to the 2x.